Hi, and welcome back. Today we're going to look at section 1.2, operations with functions. At the top of the notes it says, you will soon see that in many calculus applications, a new function can be made by combining other functions through adding, subtracting, multiplying, and dividing. Sometimes we write f plus g, f minus g, f times g, f divided by g, and g of f, or f of g, for new functions formed from two different functions, f and g. So we've got function f and function g. Now most of you are fine with the adding, subtracting, multiplying, and dividing. Some of you still need a little bit of review on what are called compositions, g of f or f of g. Those are called compositions, so we're going to look at those today. All right, but basically we're working with two functions and we're going to be combining them in one way or another to make a new function. All right, so looking at what we're going to do today, we're going to apply the indicated function operations of adding, subtracting, multiplying, dividing, or the composition, and then we're going to simplify the result if possible. Okay, so that's number one thing we have to do. And then we're going to look at what we call the difference quotient. So you guys are going to start looking at being able to find, when you're asked, find the difference quotient, which is a formula we use, but it has to deal with a lot of this functions and working with combining functions. Okay. All right, so your concepts and definitions for today listed up here. It says if f and g are two functions, then the composite function f of g is defined to be either f of g of x, or you can write it this way, f of g of x. Okay, so these are, when you see either one of these notations, it means you are composing two functions together. And when we say compose in math, we're talking about actually taking one function and putting it inside of another function in place of the variable x. Okay? Now I want you to be very careful with this notation, because I know that when you see this, okay, and you see this, they look very similar. Okay, but this notation says f of x times g of x. When there's no symbol between there, that's a multiplication problem. But here we have a parentheses between f and g. Okay, so that's a little bit different. This is f of g of x. The other way you can write multiplication is if you see it this way. Okay, these are both multiplication. This is a composition, these two. Okay, it's very easy to get them mixed up. So please, please, please make sure you're looking at and understand the difference between them. This says f of x times g of x because there's no symbol between the two. This says f times g because there's no symbol between the f and the g. Okay, so both of these are multiplication. But this one, f of g of x, there's parentheses around before each of the next things. Okay, that's composition. And obviously, you guys don't have a problem with this side. The open circle O is the other way to write the composition f of g. Okay, but I see a lot of mistakes with this and this. You guys do the wrong one. So just take your time and get familiar with the notation. Okay. All right, number 2 says, in general, f of g is not equal to g of f. Okay, those are not the same. It's doing two totally different things. So those are not equal to one another. Number 3 we need in order to get to number 4. So number 3 says, the slope m of the segment of a line which contains the points x1, y1 and x2, y2. Remember, that's point 1, point 2. Okay, is given by the formula m equals y2 minus y1 over x2 minus x1, or you can replace the y's with the function notation f of x sub 2 minus f of x sub 1. Those are exactly the same thing. Remember, you can replace the f of x's with y's. We talked about that in the last section. Okay, so given the slope formula, if we change the parameters, okay, and we permit this modification of this slope formula, it can become f of x plus h minus f of x over h. Okay, so we're going to talk about that, and that is what's called the difference quotient. So this formula here, when you're asked to find the difference quotient, is what you would be using. All right? Okay, so those are our definitions and our concepts. So let's look at some problems for today. Okay, so we're going to start with, again, combining functions based on the operation given. So number 1 says, if you're given f of x equals x squared minus 9 and g of x is 2x squared plus 3x minus 9, do the indicated function operations and then simplify. Okay? So part A says just add function f and function g. That's how you read that. F of x plus g of x. It means we're going to add function f, which is this, and then we're going to add it to function g, which is this. All right, so function f, I want to put it in parentheses just so you can see it. So there's f of x, and then we're going to add g of x, which is this. I don't really need the parentheses here, but just so you can kind of see. F of x is here, g of x is here, and it said to add those together. All right, so I have parentheses around them. I don't really need them, but what I'm looking for are like terms. So let's see what we can add together. We have x squared plus 2x squared, so that's 3x squared. I'm going to put these in descending order, so the next thing I'm going to look for are my x's, and the only term with an x in it is 3x, so there's nothing to add to that. And then you have minus 9 plus minus 9. That would give you a minus 18 or negative 18. Okay? So there is your answer for part A. So we added and simplified. All right, part B says f of x minus g of x. Now this one I am going to put parentheses around. So f of x is x squared minus 9 minus g of x, 2x squared plus 3x minus 9. All right, now this is always one for careless mistakes. When you add a polynomial, the signs stay the same. But when you subtract a polynomial, you have to change all of those signs. Okay, so be careful with the plus and the minus. So the x squared minus 9 doesn't change. You're subtracting the second piece. So all of this will change. So minus 2x squared minus 3x plus 9. Okay, remember, that minus sign is like there's an invisible 1 there. So you're really multiplying everything in here by negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 9 is positive 9. So you can think of it with the 1, or just tell yourself, anytime you have a minus sign in front of multiple terms, all of those signs have to change. Okay? All right, so now if we look at adding like terms, we have x squared minus 2x squared. That's negative x squared, or negative 1x squared, so I don't need the 1, but you could put it. Then you've got that minus 3x, and now you got a negative 9 and a positive 9, which is actually 0. So the numbers are gone, so there's your answer. Okay? All right, next says find g of x times f of x. Now this one actually has a times symbol. It's not a little open circle, it's times. So this is multiplication. So g of x, which is 2x squared plus 3x minus 9, times f of x, which is x squared minus 9. So we have to multiply. Okay? All right, now when you're multiplying polynomials, remember, you got to multiply everything in the first parentheses times everything in the second parentheses. All right, so I'm going to multiply 2x squared times x squared, and then 2x squared times negative 9. So 2x squared times x squared is 2x to the 4th, and 2x squared times negative 9 is negative 18x squared. Now I'm going to multiply 3x times x squared and 3x times negative 9. So 3x times x squared is 3x cubed. 3x times negative 9 is negative 27x. And lastly, I'm going to multiply negative 9 times x squared and negative 9 times negative 9. So negative 9 times x squared is negative 9x squared. Negative 9 times negative 9 is positive 81. All right, so I got to look for some like terms, and I'm going to put these in descending order. So I don't see anything else to the 4th power, so that's it. I only have 3x to the 3rd power. All right, now my squares, I have a negative 18x squared and a negative 9x squared, so that would give me a negative 27x squared. And then I have just the negative 27x. and I have the 81. Okay, so there is my answer for part C. Okay, all right. So sometimes there's lots of things to add together, sometimes not. You just have to remember looking for like terms. Putting your answer in descending order isn't required, but that's typical that you'll see answers written that way if you're in Hawks or when you look at our notes. So we try to keep it that way. All right, now part D does say g of f of x. Okay, that is a composition. Okay, g of f of x. So I'm going to rewrite my functions over here. So f of x. So I don't have to keep sliding my paper up. Okay. All right. So here's my two functions, same ones that were up there. I just don't want to go back up to the top. So when you see this, the function closest to the x is the function you're going to put inside of the other function. Okay. So we're going to put function f inside function g. So one of the ways that will help you is go to the outer function and circle all the x's in that one. Okay, so function g is the outer one. We're going to circle those. And in place of those x's, we're going to put all of this function. So we're going to put x squared minus 9 here and x squared minus 9 there. Okay, that's what this says to do. Put this function inside of this function. All right, so that means I'm going to do 2. And in place of this x, I'm putting x squared minus 9. And then I got to square it. Okay, so I replace just that x with function f. And then I've got plus 3. And then again, in place of this x, I'm going to put x squared minus 9. And then you have the minus 9. So I took function f and put it in here. Okay, so the outer function is the one you're putting the function in, and the function you're using to put in is the one next to the x. All right, so we got to do some work here. We're going to square first. Okay, so x squared minus 9 squared. We did this last time, but let's look at it again. X squared minus 9 squared means this. Okay, all right, so first, outer, inner, last. Got to use FOIL here. X squared times x squared, x to the 4th. Outer, x squared times negative 9, negative 9x squared. Inner, negative 9 times x squared is negative 9x squared. And last, negative 9 times negative 9, positive 81. And you can add those two middle terms, negative 9 and negative 9x squared is negative 18x squared. Okay, so that's what you get when you square that. So I'm going to put this right here. So that's x to the 4th minus 18x squared plus 81. I'm going to leave everything else the way it was. Okay, so the first thing I could do in this problem was square. You always do powers first. I just left everything else the way it was. So I squared that and I got that. Now the next thing you're going to do is multiply. So we're going to multiply 2 times each of these terms. And we're going to multiply 3 times each of those. And then the minus 9 will stay at the back. Okay? All right. So 2 times each of those terms. All right. So 2 times x to the 4th. 2x to the 4th. Minus 2 times negative 18x squared. That's negative 36x squared. 2 times 81, positive 162. Now we're going to multiply 3 times x squared, that's 3x squared, and 3 times negative 9, negative 27, and you have that minus 9. All right, so looking at our terms, putting them in descending order, I don't have anything else but 2x to the 4th. And now I have squares, negative 36 and a positive 3, that's negative 33x squared. Just add the coefficients. And now we have 162 minus 27 minus 9. All right, so add those together, you get 126. Okay, all right. And that's all you can do with that. So there is your answer. All right. And lastly, we have division. F of x divided by g of x. All right. So f of x is x squared minus 9. G of x is 2x squared plus 3x minus 9. Okay. And so we do need to see if we can factor. I know I can factor the top, but I'm not so sure I can factor the bottom. So we just need to see if we can. So let's see. So the top, x squared minus 9, that's a difference of squares. X plus 3, x minus 3. If you need help with factoring, please make sure that you review that or you get help because you will be factoring quite a bit. All right, now the trinomial in the bottom is 2x squared. So I know I need 2x times x to give me 2x squared, but I need to see if there's any way for me to get 9 in the back and then the 3 in the middle. Okay, well, there's luckily only two ways to get 9. 1 times 9 and 3 times 3. So I'm going to just start with 3 times 3. I think that would give it to me. All right, so 3 times 3, that gives me 9 at the last when I FOIL. So now I need to look at the outer and the inner. The outer and the inner has to give me 3x. So I think I can do that because 2x times 3x on the outer is 6, so make that positive. And then the inside is 3 times x. If I make that minus, I'll get 6x minus 3x, which is 3x. So that does factor. And because it does factor, I can simplify this because remember, if you have a common denominator in the numerator and the denominator, they will cancel each other out. So these will cancel out. So you're left with x minus 3 over 2x minus 3. Now, that's the answer. How many of you, if you're watching this video, are asking yourselves, why didn't she cancel out those negative 3's? Okay. All right. Remember in math, factors are multiplied together, okay? So if you have two factors that are multiplied together, and in the bottom two factors that are multiplied together, then the common factors can cancel out. But once you get down to just an individual term with just pluses or minuses between it, those are not factors anymore. That's like me saying, if you have 4 plus 3 and 5 plus 3, that you could cancel out the 3's. Okay? Can you cancel out those 3's? No, you cannot. Because if you cancel out the 3's, you would get 4/5. And we know that's not the answer to that. The answer to this is 7/8, which is not 4/5. It doesn't reduce to 4/5 because those are not factors. You're just adding numbers together. Factors have to be multiplied together. Another big common mistake. Okay, so you can't cancel those x's. You can't cancel those 3's. The only thing you can cancel with 2x minus 3 is another 2x minus 3. Okay, when they start having plus or minus signs between them, you cannot break them apart. Okay, so I know that's a very common mistake, so I just mention it so that you guys don't make that mistake. All right, let's go number 2. All right, this time we have two functions. The square root of x plus 2 is function f, and function g is 5 over x. All right, so the first thing it asks you to find is f of x times g of x. Again, that's multiplication. All right, so f of x, which is the square root of x plus 2, times g of x, which is that. Okay, now remember, if a number is just a number and there's no fraction, you can think of it as over 1. And when you multiply numerator to numerator, denominator to denominator. All right, well, when you multiply a whole number times a radical, you can't multiply them together. They just get stuck together like this. Okay, you can't make that 5x plus 10. That's no such thing. You can only multiply radicals with other radicals. And in the bottom, you have 1 times x, which is x. And that is all you can do. Remember, you can't cancel things with pluses or minuses between. Okay? All right, now B says find f of g of 5. Well, now we got a number in here. Okay, we haven't done one with a number in here. So we did this in the last section. How do you find g of 5? Well, you're going to plug 5 in for x into function g. So if you found g of 5, you would put 5 right there, 5 over 5, which is 1. Okay? All right, so we first find g of 5. We got it to be 1. That's not our answer, because now we have to find f of this number. Okay? So now you're going to find f of 1. So let's say that again. This is a composition. First thing you're going to do is find g of 5. Do the inside first. G of 5 we found to be 1. Then we're going to take 1 and replace it with this. So instead of putting g of 5 there, we're going to put 1 there. So that's what I just did there. Now, how do you find f of 1? You put 1 in here. So if you put 1 in there, you get 1 plus 2, which is the square root of 3. That is your answer. Okay, you only get one answer for these, but you need the middle answer to kind of get you through to the next step. So you get one answer, plug that in, and keep working it out. Okay? All right. C says find f of g of x. So again, we did this earlier. Okay, you can write it either way. Whichever way you like, that's fine, but you're going to take the function closest to x and put it inside of f. So again, let me write these functions down here so I don't have to slide my paper up. Okay. All right, so remember what I said. This is the function you're going to put inside of this function. So go to the outer function and circle any x that's in there. Okay, and in place of this x, you're going to put this entire function. Okay, so f of g of x, we're going to take this function, and in place of this x, we're going to put in function g. Okay? All right. Now, it says to simplify, so I'm not sure in Hawks if they want you to go farther than this. I will. I would take this okay, but if we needed to get a common denominator, which is just x, it's just a simple process. So let's say we want to combine this with a common denominator, then we'd have to multiply the top and the bottom of this fraction by x, right? The common denominator is x. So we're going to multiply that by x over x. So if we keep going, we have 5 plus, and then 2 times x is 2x. And then your common denominator now is x. So you could do it that way and get your common denominator. Okay? So either's okay with me, but I think this is the way that they would want you to simplify it to. All right, part D, we're going back to numbers. So notice, when there's a number, I get a number answer, like I did in part B, right? And if there's an x in there, I'm just going to have x's in my answer. So now with part D, since I have a number, it's going to be like we did with that one. All right, but this time, the inside function is f. So we're going to start by finding f of 2. What is f of 2? Well, we're going to put 2 in function f, so that would be the square root of 2 plus 2, which is the square root of 4, which is 2. Okay, so remember, that's not your answer. Now we're going to take 2 and replace that with the f of 2, because f of 2 equals 2. So in place of f of 2, we're going to replace it with what we got, 2. So now we're going to find g of 2. So now we're going to put 2 over here. So that is 5 over 2, which is 5/2, and that's it. Okay? All right. Part E is the opposite of C. So this is good because you can kind of see, remember, one of the definitions was f of g of x is not equal to g of f of x. So these are not the same. So let's talk about why that is. So on this one, the outer function is g. So on this problem, you would circle this x and put this function in there. Okay? So g of f of x says take function g, 5 over, and in place of x, put in function f, which is that. Okay? All right. So there is your answer for E. So you can see they're not the same. Okay? Not the same. All right. Moving on. Okay, number 3. This one is multiplication. Find f of x times g of x. Here's function f, here's function g. We're supposed to just multiply them together. So function f times function g. All right, so like I said, when you have a fraction, let's make everything a fraction because that's easier to see. And you're going to multiply straight across. So we're going to multiply 10 times x squared plus 3x. And in the bottom, you got 1 times x, which is x. All right, now this one we can simplify a little bit because we can multiply the 10 through and then factor out an x. So let's keep going on this one. So let's do the 10 first. So 10 times x squared plus 10 times 3x. I think I said 10 times. Yeah, 10 times x squared is 10x squared. And then 10 times 3x is 30x over x. All right, now, if I can cancel an x out of both terms, then I can keep going. So I can do that. I can take 1x out of here and 1x out of there. So if I take 1x out of each of those, okay, if I take 1x out of here, it'll leave me 10x. And if I take 1x out of here, that just leaves me 30. So if you can take the bottom out of both of the numerators, then you can keep doing that. Those are factors because that's multiplied, remember? So we end up with just 10x plus 30. Okay? All right, number 4. F of x is a square root function, x minus 1. G of x is another rational function. And this time you're asked to divide function f by function g. So function f divided by function g. Okay? All right, well, remember when you divide by a fraction, you multiply by the reciprocal, right? So remember, like if you were dividing 1/2 by 3/5, that would be 1/2 times 5/3, right? You flip and multiply the bottom. So that's what we're going to do here. So this is the square root of x minus 1 times, and then we're going to flip that to x over 6. Okay. Remember, that's the rule for division. You multiply by the reciprocal. All right, so if we multiply straight across, and remember again, this is over 1 if it helps you. So x times the square root of x minus 1 is just that. Remember, you can't multiply numbers in radicals. They just multiply like that. And 1 times 6 in the bottom is 6. Okay, and that's all you can do with that one. All right, number 5, we have f of x is a polynomial, x squared plus 2x. And we have g of x, another polynomial, 5 minus 3x squared. And we're supposed to find f of x minus g of x. This is the one you need to be careful of. Remember, when you subtract, you got to change some signs. So put these in parentheses to start. So f of x is x squared plus 2x minus g of x is 5 minus 3x squared. Okay. If you put them in parentheses, it kind of helps you see what you need to change. So these are going to stay the same, but minus here means both of those signs have to change. So you have x squared plus 2x, and then this is going to become minus 5, and that's going to become plus 3x squared. Now you can add your like terms, and the only like terms I see are x squared plus 3x squared, which is 4x squared, and then you have the 2x and the minus 5. There's nothing you can add to those. Okay? So that's that. All right, number 6 is a composition. Find f of g of x. That's not multiplication, that's a composition. So remember, outer function, and what you're going to put in there is the inner function. So we're going to put this whole thing in place of that x. That's what that says to do. So we're going to do 3 over x squared. Okay, we put function g inside function f. And all we have to do is square the top. 3 squared is 9. Square the bottom. X squared is x squared. And that is it. Okay. All right. All right. I'm going to go ahead and stop again, just trying to have these videos not be too long, so 30 minutes. So let's stop, and I'll pick up on part 2 with number 7. So I'll see you back here in a few minutes.